Okay, so example 2, evaluate the integral from -2 to 1 of 2x by the limit of the Riemann sum, aka you have to do this by theorem 4. And then we have this follow-up question, what does it mean? So we're going to start out with that definition, or that, it's not really definition, the theorem is how it's listed, theorem 4. So I'm just going to write that out. We have the integral from a to b of f of x, and then we attach that dx on the end, and that's the limit as n goes to infinity of the Riemann sum. The sum is from I equals 1 to n of f of x sub I times delta x. And we need to remember that delta x is the width of the interval, b minus a, over n. And x sub I is equal to a plus I delta x. So that'll be the right endpoint on each subinterval. What's our a in this problem? -2. What's our b? 1. We're just getting that from the notation, the integral notation, the -2 and the 1. And their placement is telling us the a and the b. The a is the bottom one, the b is the top one. Good. What is our function? F of x. It's 2x. And I can tell that again by comparing theorem 4 stuff with what was given. So we need what we have there. The next thing is to find delta x, which is b minus a over n. So our b is 1, our a is -2. That's over n. So here we get 3 over n. Then we find x sub I. Our a is equal to -2. And then we have plus I delta x, where delta x is 3 over n. So x sub I is a little more complicated here than it was in example 1. And it turns out that makes this problem more of a pain. Pretty significant added pain factor here when a is not 0. Just a heads up. So now I can go ahead and write this. The integral from -2 to 1 of 2x is equal to the limit as n goes to infinity of the sum from I equals 1 to n of f of, and then my x sub I found is -2 plus 3i over n. Delta x we found is 3 over n. So next thing is I'm going to use the actual function. I haven't done that yet. And then everything will be plugged in. So this was the f notation, and it seems like we should be done with this, but we're not. So what is the function? Well, the function was 2x. So this simply becomes 2 times -2 plus 3i over n in parentheses. That is the f of x sub I. It's kind of basic in this one. And then the delta x is the 3 over n. It's a little hard to tell. So, questions so far? So if we do this in the way I do, is I'm going to try to break this up into separate terms. If I use the distributive property here, I'm going to have 2 terms. And then I can have 2 sums, and then deal with each of those separately. So that's my goal here. I'm just going to start out by distributing the equivalent of 6 over n, because I got a 2 out front, and I got 3n behind. So 2 times 3 is 6 over n. And so I'm going to have -12 over n for the first term, and then I'm going to have plus 18i over n squared. So let me check that. Much easier on the i's. Then I have a property that says I can look at the sum of each of those separately. So I'm going to write that. So I did there. So now you're looking for i's that follow the sum. Do I have any i's that follow the sum? First sum, I have negative 12 over n. There's no i's in there, right? So here's where people get confused, because it's like I'm given the sum of I squared, and the sum of I cubed. And I can't use those. Like, what do I do with this sum? And so the answer to that is you were supposed to memorize that the sum of a constant is equal to what? NC. That's what you use. Because that's what we have. We have the sum of a constant. And so our constant is negative 12 over n. And so what we're going to have, let me just address that part by writing the next line, is we're going to have negative 12 over n times what? So that's the constant. That's the C. N. Sum's gone. Now look at the next one. 18i over n squared. So if you don't want to write this stuff, it's okay, but I'm just going to do it here to kind of highlight my work better, otherwise it'll look kind of messy. That 18 over n squared is the constant part. The sum of I is the part I have the formula for, and that's given. So that one was just the n times n plus 1 over 2. So now when I write this next line, appreciate that I got rid of the sums, and there's no i's. So are there any questions at this stage? It's good stopping place. No sums left. You got to do that before you do the limit. You can't do the limit until you get the sums gone. Okay, now the next step is you can simplify usually what's here big time. So in the first one, for example, the first term, how can you simplify that? The n's cancel, right? So do it and you get negative 12. That's a piece of cake to take a limit of when it comes time. In the second term, what can you simplify? 18 halves is 9. Got a pair of n's that cancel, right? So we get 9 parentheses n plus 1 over n. So that second limit is pretty easy to evaluate. Well, negative 12, the limit as n goes to infinity, that is negative 12, so I'm going to take that out front. Plus the limit as n goes to infinity. And I'm just going to do some algebra on this one. Mix it up. I'm going to distribute the 9. N's cancel. So negative 12 plus 9 plus what? 0. Limit as n goes to infinity of 9 over n is 0. So what's the result here? Negative 3. So if I had not told you that little tidbit in the beginning about, hey, you can get its net area and what it represents, you might be like, hey, that's wrong because I can't get negative area, but we don't dismiss it right away because this could actually make sense. So that goes to the what does it mean, which is really open-ended. I wouldn't ask this in minutes. But what I was trying to get at is like, well, why is it negative 3 or what's going on here? So the directions were, hey, do this by the limit of the Riemann sum theorem for, please do it that way. So we did it that way. But let's backtrack. What does it mean to take the integral from negative 2 to 1 of 2x? Well, the function is 2x, right? What does that graph look like? What's a graph of 2x? What does it look like? Is it a parabola? It's just a linear equation. It's just a line, right? And then we're doing this on negative 2 to 1. So let's graph that and see what it looks like. So just a quick sketch here. Here's the line. I'm just graphing it from negative 2 to 1. And so this integral, what it's representing is the area that's made with the x-axis. So since the curve is less than 0 from negative 2 to 0, that's the area there, plus the positive area from 0 to 1. So looking at the picture, does negative 3 seem like it could be a reasonable answer? Yeah, because the net area of this thing is negative. So at least we can appreciate that a bit. Now, looking at this picture, could you find that area exactly without a definite integral, the limit of the Riemann sum? Yeah, it's just triangles, right? So our first example was a parabola shape, and it wasn't like something that we already knew how to find the area of. So just quickly showing you how you could find this, just using some geometry, negative 2 to 1, and 2x is our function. This would be like, let's label these A1, A2. This would be like negative A1 plus A2. And you have a problem kind of like this on the homework, which I'm sure you don't care about right now, but you will, hopefully, eventually. So it's 1/2 base times height, so the one that is labeled A1 is going to be 1/2 2 times 4. The one labeled A2 is just 1/2 1 times 2. So negative 4 plus 1 is negative 3. So I didn't actually directly answer that question, but that's kind of what I was trying to get at. You know, this is what it means. I drew a picture. I could find it this different way. It's just area triangles in that area.